Hello, everyone. My name is Sergey. I'm software engineer at Uber Presto team. And today, I'm going to talk about the journey that we started at Uber for Velox and usage of Prestissimo. First, let me share the scale of Presto at Uber. So right now, we have around 7,000 weekly active users. We do run 650,000 queries per day. Read over 50 petabytes of data. We are span across 4 data centers, 2 on-premises and 2 on cloud. And we are actively migrating to cloud. 16,000 hosts and over 50 different sized clusters. There are some express clusters. There are some batch clusters, interactive clusters. In terms of workload, only 15% of our queries are actually accounting for interactive. So it's like ad hoc queries. Around 85% of all the queries are coming from batch scheduled queries. Why do we want to consider Velox? So Velox, or how usually people, sometimes people say Velox or Velox, I'm not sure. It has proven itself from Meta and like other companies. And what we do see, like this is the chart like which shows like the breakdown on the different operators in Presto. We see that 90% plus of CPU cycles that we spend is actually spent on the scan filter and projection. And obviously, Velox with its SIMD optimizations and like filtering capabilities should be helping us a lot, right? And we did some POC benchmarkings early last year. So, and we did confirm that the workload, which is very scan heavy, could lead up to 7x improvements in terms of CPU time. And so, yeah, we decided to start the journey and start migrating and like building tools around development and start migrating to Prestissimo. Of course, we faced the early challenges. Some of them were like just basic stuff, like lack of tools for C++. So Uber is actually not like a C++ shop at all. And nothing in the code base is in C++, so mostly everything is in Go and Python and Java. Even such basic stuff as like, I don't know, maintaining like a Debian version, so we run vanilla Debian instead of like Ubuntu or maybe CentOS, dependency management and everything, remote developer environment setup, like DevBots. It was all kind of challenging at the beginning, so lack of observability and other tools, like for instance, worker metrics were not actually there, and it's something very important we need to keep track of. Of course, in the early stages, we saw tons of worker crashes and OOMs. Some of the crashes were actually caused by dependency management, like one of the cases in open source, and thanks to a HANA team from IBM for helping us to pinpoint lib unwind issues. One of the first things we actually invested in was metrics integration using Apache Prometheus. So within Uber, we use M3. It's an open source metric system for Prometheus. And it was a collaborative effort with HANA from IBM. Detailed implementation proposal is present in the linked RFC. And as per proposed architecture, there is a subprocess within the Prestissimo process. It buffers Prestissimo process metrics and also serves as a streamlined HTTP server. And the mentioned subprocess above is implemented using the Prometheus CPP library to buffer metrics and make them available as an HTTP endpoint for the M3 stats collector to scrape them. So this is like a rough architecture of the metrics integration, which was open sourced and collaborated together with the HANA. Next challenge is we understand that Presto on Velox, Prestissimo has been widely used and adopted by Meta, but there are still some differences, right? Like some of the examples is actually Parquet. We use a totally different data format compared to Meta. Meta using Dwarf. And we couldn't start migrating without actually proper verification. So Presto Verifier was actually proven to be very helpful for us, especially in the early stages, to build the confidence around the support of the Presto on Velox. We integrated into Uber's infrastructure. We use it very extensively to onboard the first 5% of our traffic. 5% of like global traffic. And we found it not quite scalable to run verifier for every single onboarded query shape. And going forward, we're actually migrating more like on the shadow testing base. So basically, if queries can actually succeed, we do like mark them as eligible for Velox, but we do still run continuous verification on the queries selectively. And honestly speaking, we didn't face too many issues with the verification. I think Amit was sharing some of the SQL with like different like regex expressions and some complex regex. So probably maybe our customers don't actually write such complex regex, but definitely like Johnny versus Ritu and other things like Jackson and SimGJSON bring some differences, but we didn't face anything, and our first 5% of the traffic was quite randomized. One of the major things was, of course, memory tuning. So we did end up adopting memory arbitrator. I'm just like putting some configs over here, which we use for the total of about 250 gigabytes of RAM. We do see that since we are using Parquet and like memory management in Velox, yeah, it's doing a great job, right? Like on the overall. But many of the things, like such as third-party libraries, are still actually using direct memory allocation, and it's actually possible that the processes are actually going to be killed by the underlying system, which is running our clusters. So in the recent development, for example, we faced an issue with Parquet footer metadata loading, right? Like we've seen some examples of like, we have some tables which are like 5,000 columns wide, right? And many of those columns are actually structures, right? I think it's something similar that Masha was sharing about, not at that scale, but in earlier presentation where there was like 13,000 column-sized row. And yeah, so some of our footers are actually more than 100 megabytes, so which is quite like huge, right? So compared to the industry standard, where the sweet spot is like less than 1 megabyte. But yeah, this is our state, and yes, we have to do something about it. Memory cache proved to be helpful, and early actually I think memory cache was causing some issues when it was misconfigured, but like eventually we could actually enable the memory pushback, and like our workers are more or less stable this time. Now the biggest, the biggest part is about how do we actually migrate the queries, so query routing infrastructure. So luckily, while working on Presto and infrastructure and ecosystem for quite a few years at Uber, we built some systems which we just could basically successfully reuse. So queries are routed to Presto and Velox queries, Presto and Velox to Prestissimo based on query fingerprint eligibility. What is a query fingerprint? We parse the query, strip off some of the like literals, like string literals, and we obtain the hash of a query. So there is exact and there is abstract fingerprint. If date string just changed or something like that, or maybe like some dates are changed, it's not really matter. That doesn't really matter much. It means that the query still remains the same, but underlying data is kind of similar shape, so the tables are still the same. So portion of the queries are still running through the Presto verifier, and in other cases, we at least ensure that the query can run in Velox through the continuous shadow testing. So essentially, we have a continuous shadow testing, which is adding to the pool of supported query fingerprints. And queries that are failed during shadow testing are analyzed and prioritized accordingly to further improve query coverage, and that's how we actually compute the query coverage for us. So this is basically here we can see that whenever Presto actually query completes, we have Presto event listener, which will log the completion event to the Kafka topic. And then based on that, we have a modulator service, which is our like shadow testing framework. It can shadow the queries which have not been shadowed yet to the Velox staging cluster. So we want to avoid running the same query multiple times for the sake of saving capacity. We do save the list of supported fingerprints in the storage, and then we have pre-on service. Name doesn't really matter too much, but it's our like distributed like service, like coordinator-only service, which can do like parsing of the query, and in live actually detect the query fingerprint. It will actually, check if this query fingerprint is actually eligible, and if it is, it will be submitted to Velox cluster. And for now, since we are around 20% in migration on the cloud. We are still actually falling back to to the Java clusters in case of a query failure. But so far, this is looking good. Parquet reader stability fixes and gaps. So this was one of the major issues for us because nobody else is using Parquet. Well, I shouldn't have said that. So like we started collaborating with Pinterest right away, and like not so many other companies like who actually onboarded like last year used Parquet. But yes, there is Pinterest. So we worked together with Pinterest and with Ahana, with the help of Ahana. And we did fix some things like complex type handling. We resolved issues related to the parsing of null values in complex types. And they actually previously resulted in correct output. Also, Pinterest team shared some technique about how to use unit testing framework that leverages the existing unit tests from Presto Java implementation. It basically generates Parquet files using Java unit testing framework, and we ensure that we can actually run and read them using using Presto and Velox. Backwards compatibility is a big issue as well. So we run Parquet version 1.10. Right now in open source, we already have 1.15. And we address multiple backwards compatibility problems, some schema evolution problems. And CLAC support, CLAC stands for column level access control, is the major contributor to support coverage for us. So it could actually unblock for us about 40% of the queries. And my colleague Yunfei will talk about this in more details in tomorrow's session. So this is the data for the first actually 5% of the traffic. So we just did some benchmarking, detailed benchmarking of comparing the same setup of Velox on Prestissimo with 100 nodes versus Java with 100 nodes, and also Prestissimo with 70 nodes and versus Java with 100 nodes. We can see that under the same circumstances, same capacity, CPU time has been reduced 3.7x, elapsed time reduced 2.5x, and total number of queries which we processed was like 40K, and unique query shapes was 1,000. Even if we actually cut capacity by 30%, so we still see huge improvements in CPU time, 3.5x improvement in CPU, and 1.5x improvements in elapsed time. And here we can see that Java we could actually push Java quite heavy on the CPU utilization. So in many cases, we actually could achieve like close to 95% utilization on the CPU. With Velox, we couldn't actually push it closer to maybe like 60% of the average utilization. So current migration status is we support over 10,000 different query shapes. We run 3 Prestissimo clusters with 30% capacity savings and migrated 20% of Presto Cloud. We're also moving from JSON to gRPC format in GCS connector. It's also showing us great results in like latencies for scanning. Parquet write evaluation. So we just evaluated this. We don't have much of the write workload. Most of our workload is select-only queries. But we did identify some issues we are planning to prioritize, and some of them were actually filed to open source. So the current implementation does not support end-to-end schema updates. Most of the common data types actually working fine, but there are some issues with time and timestamp. Compression ratio, we saw that Java Presto is producing the Parquet files much smaller size. And we filed some PRs to make a few of the coding policies configurable. And there were some minor Spark SQL compatibility issues. But yeah, they will be looked into. And also wanted to add a slide about the CLP connector. It's something we added in a collaboration with like CLP developers. Basically, it's a storage engine specifically designed for schemaless and semi-structured logs. It produces high compression ratio on log data and efficient queries, and it exposes a table-like interface for searching logs data, and so it allows us to search logs with 2x higher compression and 3x faster query compared to Parquet. This CLP connector RFC is linked over here, and we are adding it to open source as well. Geospatial support is a big topic for us. Obviously, we are Uber. We do things like polygons and stuff, and SD contains. They account for about 15% of Presto CPU time at Uber. There is an ongoing discussion, which we also collaborate with, and we are trying to contribute the pull request to the open source about supporting those like geometry functions and spatial joins. As for now, we're just trying to make it work, because spatial join is not actually supported natively, but for now we are using inner loop join, but basically first trying to make it work and then make it fast. And last but not least, wanted to share some thoughts about Uber's open source strategy for Prestissimo and Velox. So we have actually a separate fork for Prestissimo, and it's a separate fork compared to Presto Java. Currently, Prestissimo is running with 291 release, and Presto Java runs on 287. Prestissimo is like more lightweight version because it has like C++ part, and the Java part has minimal changes for Uber to make it work with Uber infrastructure. But we stripped away a lot of stuff which we added historically because we don't need them, because we don't run Java workers. And our end goal is to pull the changes from open source on a weekly or maybe like closer basis. It doesn't mean we want to run this directly in production, but the reasons we want to do that is debugging time is never actually wasted. So we've seen some issues when like we pull the latest like open source release or something like that, and in 2 of the 3 latest upgrades, we faced issues in Parquet. And obviously, the Presto release is not probably tested sufficiently enough for us because it runs on the TPCDS, which doesn't really cover like many of the use cases like complex data types for Parquet and other things. And we face some issues when we're debugging something like for a quite extensive amount of time, and then we find that it actually already been fixed in 3 or 4 weeks down the road. So we want to make sure that this debugging is never wasted. It's actually easier because we want, like latest upgrade, for example, is going to be like 300 Presto commits and 400 Velox commits. We don't want to be alone. We want OSS community to be our team, and issues we find and fix are community issues as well. We also want to know what we pull, because like oftentimes upgrades are basically, hey, we upgraded it and we are happy because everything is building and passing tests. But we oftentimes don't know what features we actually have pulled. And by taking a closer look, we will try to contribute by pull requests, by comments on the pull request, and tracking more frequently what's actually changing. Avoiding dual work, like for instance, the work which we do for the CLAC, column level access control, it actually has some conflicts in the master, so we basically have to maintain like 2 versions of the same code. So we want to avoid that. And we want to step out of isolation and engage actively with open source community. Learn from community best practices, coding standards, and debugging tricks and other things. Future work. Exploring mixed worker setup to run queries with unsupported catalogs. And geometry functions is a big thing for us. Continue work on query coverage percentage support. Continue migration of batch workload. Eventually, we want to move away from the fingerprint-based onboarding because we want just to do this live to detect if the query is supported by Velox or not. And of course, like from there, we can move to supporting interactive traffic. Thank you.